Hello and welcome back to Bioclass Bytes. In this video, we are going to talk about the Milky Way galaxy and the solar system. Don't forget to subscribe to my channel and like and share this video. These are the unit and lesson titles for this video series. And in this video, we are going to focus on the Milky Way galaxy and the solar system. You must have discussed this lesson when you were in grade 7, so this video will just be a review of those science concepts. So the Milky Way galaxy is the galaxy in which the solar system is located. It derived its name from the from what it was called by the early astronomers when they looked up into the sky and saw it is as if milk has been spilled across the sky. So we can describe it as a spiral galaxy that's just one of the billions of galaxies in the observable universe. This image is a panoramic view of a computer generated approximation of how the Milky Way galaxy when seen from this angle. The Milky Way galaxy is said to be moving with a velocity of 600 kilometers per second, and they say that the oldest stars of this galaxy are as old as the universe itself. The Milky Way galaxy can be described as spiral, and it has possibly a black hole on the bulge of its center, and surrounding it are its arms. So the solar system is found on its Orion arm, around 26,000 light years away from the center of the Milky Way galaxy. So this is where we can find the solar system and the Earth from the top view, and then from the side view, that is possibly where we are located. So the Milky Way is a galaxy is a dense collection of stars that lie on the plane of the galactic equator. I recommend that you watch the following videos. This is entitled How Big is the Milky Way? I will provide the link in the description below. This one is a comparison of the different sizes of celestial bodies entitled Universe Size Comparison. I will provide the link in the description below. This one is from NASA. These are some of their many interactive applications from their website. So this one is entitled Eyes on the Earth. This one is Eyes on the Solar System and Eyes on Exoplanet. I recommend that you check this out. So this is a diagram that may not accurately represent the different members of the solar system. However, we are familiar with this. So we have the Sun, followed by the inner terrestrial planets, Mercury, Venus, Earth, and Mars. Then we also have Jupiter, Saturn, Uranus, and Neptune, your gas giants. Again, I would like to emphasize this is not an accurate representation of their distances from each other, and this is not an accurate representation of their orbits around the sun. So this is just to represent the comparison of their sizes with each other. This shows us the formation of the solar system according to the nebular theory. So scientists say that, according to research, the birth of our solar system possibly began as dust and gases, called nebula, started to gravitationally collapse on itself. Then eventually, the nebula contracted into a rotating disk, okay? And it is heated by the conversion of gravitational energy into thermal energy. So it's very, very hot during the first um, years of formation of our solar system. Eventually, our nebular cloud started to cool, which caused rocks and metallic material to condense. Okay, and eventually they, due to repeated collisions with each other, since their orbits were not yet stable, they gradually coalesce or combine together from dust-sized particles into asteroid-sized celestial objects, which eventually becomes the planets within our solar system um, after a few million years. So this is the possible formation of our solar system. So again, these are the major celestial objects found within our solar system. So we have the sun, which is our star, followed by the terrestrial planets, and then the asteroid belt. Then outside you have your gas giants, then outermost belt, the Kuiper belt. But again, no, I've mentioned already that this is a representation of how they possibly appear within our solar system. Now here at the bottom shows us the distances of each planet from the sun using astronomical unit. Okay, so 1 AU, 1 astronomical unit, is equivalent to the distance of the Earth from the sun. So that's around 150 million kilometers. So as you can see, the terrestrial planets are found within the 1 to 2 astronomical unit from the sun. Jupiter is around 5 AU. Saturn is, say, between 9 and 10 astronomical unit. Uranus is more than 19 astronomical unit. And very, very far from us, we have Neptune at 30 astronomical unit. I recommend that you watch this video from National Geographic entitled Solar System 101. This one is a very interesting video summarizing everything about the solar system. I'll provide the link in the description below. I also recommend that you visit this solar system exploration from NASA. I'll provide the link in the description below. And they have this page on the 10 need to know things about the solar system. Some trivia about our system. So number one, our solar system is made up of a star. Okay, that's our sun. 8 planets and countless smaller bodies such as dwarf planets, asteroids, and comets. Our solar system orbits the center of the Milky Way galaxy at about 828,000 kilometers per hour. Okay, so we are one of the galaxy's 4 spiral arms, specifically in the Orion arm. It takes our solar system about 230 million years to orbit around the galactic center of the um, Milky Way galaxy. And there are 3 kinds of galaxies: elliptical, spiral, and irregular. As you can see, the Milky Way is an example of a spiral galaxy. And our solar system is a region of space. It has no atmosphere, but it includes many, many worlds, many, many planets, including our planet. The planets of our solar system hold more than 150 moons in their orbit. Okay, we have one of those 150 moons. The 4 giant planets all have rings, but none as spectacular or as obvious as Saturn's rings. More than 300 robotic spacecraft have already explored destinations beyond our orbit, and we have 24 astronauts who already orbited the moon. And so far in our solar system, our planet is the only one capable to sustain life. However, we are still looking for other planets and checking their environment if it is suitable to sustain life. NASA's Voyager 1 is the only spacecraft so far to leave our solar system. Okay, so again, I'll provide the link to this page from NASA. You can find it in the description box below. So again, I would like to emphasize, please try to visit these applications from NASA, okay? One of which would be Eyes on the Solar System. This one, with this link, you can click. You can find it in the description below. It shows us the different orbits in real time, okay, of the planets of our solar system. So you can actually move around your view. You can zoom in on the planets or on the different moons that you can find. And below, you can find a lot of trivia about the planets of our solar system. So this one is a very interesting interactive website. I recommend that you visit it. The sun is the star at the center of the solar system. It is a hot ball of plasma, and it accounts for almost 99% of all the total mass of the solar system. I recommend that you watch this video from National Geographic channel to learn more about the sun. I will provide the link in the description below. These are the inner terrestrial planets of the solar system: Mercury, Venus, Earth, and Mars. These are the outer gas giants: Jupiter, Saturn, Uranus, and Neptune. These shows us the comparison of the internal structures of the different planets. So as you can see, the terrestrial planets all have in varying sizes, no? A metallic core, rocky mantle, so metallic core. Earth, we even have an inner metallic core. But Mercury, Venus, even the Moon and Mars has a metallic core followed by a rocky mantle and then outermost rocky crust. While in Jovian planets or in the gas giants, they have a very small, in comparison to their overall size, a rocky iron core, okay? Jupiter, Saturn, Uranus, and Neptune, then followed by a liquid metallic hydrogen. So this is their only rocky material, okay? Then they have solid material. Then they have a liquid metallic hydrogen, liquid molecular hydrogen, then followed by their thick layers of gaseous hydrogen and helium, and then the visible clouds after that. Okay, so that's the reason why they're called gas giants. They are mostly made up of liquid and gaseous layers. I recommend that you check out this video from CGP Grey to see which planet is the closest to Earth, and you might be surprised with the answer from this video. And this video will be an interesting explanation still from CGP Grey on why Pluto is no longer considered a planet. I will provide the links to his videos in the description below. The solar system is also home to two main belts of small bodies: the asteroid belt, which is found between Mars and Jupiter, and Kuiper belt, which lies beyond Neptune's orbit. So these are mostly made up of rock, metal for asteroid belt, and water, ammonia, and methane for the Kuiper belt. I recommend that you also look into this playlist from National Geographic on the different planets and different members of the solar system. I will provide the link to their playlist in the description below. This is another application from NASA that tries to explore exoplanets, or those planets that are found outside the solar system. I will provide the link in the description below. The Earth is the third terrestrial planet from the Sun. This is the only known planet in the world that harbors life. And this is the planet on which we live on. I recommend that you watch this video from National Geographic channel to learn more about the Earth. I will provide the link in the description below. The Earth is said to be around 4.5 billion years old, and this is a very special planet because life was possible to survive here. So this video from Open Mind tries to answer the question, why is there life on Earth? I also recommend that you visit this article from National Geographic that also still tries to answer the same question. I will provide the links in the description below. So why is there life on our planet? So these are the identified reasons, and let's try to look at them one by one. So first, our location is far from many hazards. Needless to say, for life to exist, there's a lot of requirements or parameters to be met. And it just so happened that our planet is located in such a way that we are protected against, or we are protected against asteroid strikes or meteor crashes and all those. Our sun is a stable and long-lasting star. Our sun is also the source of energy of life from our planet, and we are just at the right distance away from it. We also have the right stuff to host a dynamic core. We have a big moon to stabilize our actual wobble, and we have an ozone layer to block harmful rays, enabling life to exist. And we have a magnetic field that blocks harmful radiation from the cosmos. The origins of life from our planet will be tackled in depth when we go to Unit 3, Introduction to Life Science. But just to give you an overview, in terms of origins of life from in our planet, most scientists agree that the beginning of life here were due to the accumulation of simple organic molecules. And when we say organic, these are carbon-containing molecules, and they accumulated in the primordial soup, okay, or in the bodies of water during the primitive Earth. Okay, so the molecules originated from the reactions of chemicals with the Earth's physical environment, including the atmosphere, um, and the different gases present in our primitive Earth, and then eventually, those um, uh, chemical compounds interacted with each other to form larger and larger complex molecules until they had the ability to replicate themselves. And following the mechanisms of evolution through natural selection, variations of these chemical compounds eventually allowed them to develop different sophisticated characteristics, which gave rise to their adaptations to survive in the planet. And then they are known as the precursor, possible precursor, or the primitive ancestors of life on our planet. So we can actually find these stromatolites in Australia. So these are these are mounds, as you can see here, mounds built billions of years ago by cyanobacteria, one of our primitive possible ancestral organism. Now, most scientists have agreed that this could possibly a good explanation on the origins of life on our planet, and it was tested um, in 1950s by Stanley Miller in the famous Miller-Urey experiment, okay, wherein they try to simulate the conditions of the primitive Earth and see if it is possible to derive organic compounds from those present molecules in our environment. And they were actually very successful. So they were able to create the or simulate the primitive Earth's physical environment, and what they find was different amino acids that are present in his experiment. So they were able to create building blocks of life through simulation or recreation of the possible environment of our planet back then. So it was a very important experiment, and we will talk more about it when we go to Unit 3. So this is a very big achievement for science and for humanity when we were able to actually reach the moon and study it and get lunar samples and then return back to our planet. Okay, so here in this image, astronaut Harrison Schmitt was sampling lunar surface, and then what they find is that the lunar soil called the regolith lacks organic material, okay, or carbon-containing molecules. And one of the possible explanation for that is that it's not considered a true soil, so life may not be possible on our moon, our satellite. I also recommend that you watch this video to scale the solar system, because the people here try to accurately represent the distance of the planets away from each other and away from the sun. This is actually a very good video, and this is what I'm always trying to say to my students, that we are just one tiny speck in this vast universe that we have. These are some of the latest space news. Though they may not be as latest, but they're still um, worthy to know. So in 2017, we have actually created one image that summarizes or makes a composite of all the parts of the observable universe. So you have here the solar system at the center, then the spiraling arm of the Milky Way galaxy, followed by the all galaxies around us, and then the outermost reaches of the observable universe. So they try to fit into one image the observable universe. So kindly check this article out. I will provide the link in the description below. So for more latest space news, I recommend that you subscribe, or you follow NASA's page on solar system. I will provide the link in the description below. Also, scientists were able to actually capture the image of a black hole for the first time. So you could check out this article from The Guardian, the link in the description below. This also is a video trying to explain that first image and why was it so impossible to take a photo of it in the first place. So I will provide the link in the description below. I also recommend that you download the app Google News and you subscribe to the science channel or science category so that you will always be updated with the latest space news. So here are the possible futures of the universe. So scientists try to determine what could be the fate of our universe, and these are their three theories. The first one is Big Freeze. They say that observations suggest that the expansion of the universe will continue forever. So the from Big Bang up to expansion of the universe, it will just continue forever. However, as it tries to occupy more space, eventually, following the laws of thermodynamics, the universe will eventually become uniform in terms of temperature. It means that it will become uniformly cold all throughout. So, life on our planet may cease to exist once the universe becomes too cold to sustain life. The second would be the second possible future would be the big crunch. So it says here that the expansion of the universe will stop accelerating and will eventually slow down. So the dark energy may become weak enough and gravity might ultimately win the tug of war and the universe will pull it back on itself. So the universe will keep on expanding until it reaches a certain point and then it will zoom past back to its origin and then destroying everything as it goes back to its origin. The next will be the big rip. It says here that the universe will continue to expand. However, there might be some cracks along the way, or it will destroy itself as it tries to continuously expand. So if dark energy gets stronger, it may be enough to counteract even that, expanding not just the space between the galaxies but the space within them. So this illustration tries to show us what possibly could happen, starting from Big Bang and then the inflation, then the creation of the galaxies, and then continuous expansion. And there will come a time that the atoms between the galaxies will just rip, or atoms connecting the galaxies will just rip, and then it will just tear apart, and then everything will just break apart. But do not worry, approximately all of these possible futures could only happen 22 billion years into the future. So to discuss more about the three possible ways that the universe could end, I recommend studied video, and I will provide the link in the description below. So this is your inspiration for your reflective journal log. Kindly read these two slides that are available in the online library. So I hope that you will feel something in your heart when you see when you read and understand these two slides. Now, the cosmos within us is just a special segment I included here to help us realize how special our planet is and how insignificant it is actually when compared to the rest of the cosmos. So this is Neil deGrasse Tyson explaining how we're connected to the universe. I will provide the link in the description below. And this one is from Smithsonian Channel, explaining why we are all made up of stardust. Okay? And Carl Sagan, one of my favorite astronomers, astrophysicists, philosophers, and explaining that we are actually the way for the cosmos to know itself. So to give you an overview on those last two videos, um, when Carl Sagan said that we are made up of star stuff, he refers to the nitrogen, the calcium, the blood molecules, the carbon, which were all used to be part of a collapsing star. So if you actually analyze it closely, every atom that makes up our planet right now used to come from the remnants of a star that exploded a long time ago. So a star exploded in the past, it exploded, and then from that material, our star was formed. From those debris, our planet was formed, and then from that planet, life emerged and life evolved, eventually reaching our status right now, reaching who we are right now. So if you actually go back in time and try to trace everything of our origins, we used to, our molecules that make up our body used to come from that star. So that's what he meant when he say that we are made up of star stuff. Okay? And Carl Sagan also said that the cosmos is within us. Since we are made up of star stuff, the molecules in our body used to be part of the of a star, or used to be the molecules of that star. And he said that we are the feeling parts of the universe. We are the knowing parts of the universe. We are the exploring parts of the universe. So we are part of the universe because our molecules are made up of those celestial objects, and we are conscious right now and thinking about it. So we are a way for the universe to know itself. I also recommend these videos from TED. These are TED Talks. We are Dead Stars from Michelle Thaler, and we're all starred. We are all stardust, and why that should make you feel awesome from Dr. Natalie Hinkel. I will provide the links in the description below. That ends our video. I hope you learned something new. Don't forget to subscribe to my channel and like and share this video. Till next time, goodbye.